All right, for our second round of graphing, we're going to spend a lot of time looking at parabolas. So what's a parabola? We've all learned it. We've all tried to forget it. It's a U-shaped function. It can be a right side up U or an upside down U, and you get it by having a second degree equation. So what that means is the highest exponent you see or you can make by expanding will be 2. So if we look at our examples, fairly obvious, that's highest degree, biggest exponent is 2, fairly obvious. If I look at this one, the third one, I see an x and an x, but if I were to go and expand that as I start the process, yada yada yada, suddenly my highest exponent is 2. And likewise, in the fourth example, I have just a single x, but the whole binomial is squared, and we know by this point that if you do this math, suddenly you're going to make x squared, yada yada yada. So these are all equations that will make parabolas. Some of the neat properties of parabolas are that they are symmetric. So that means they are mirrored around a vertical line or plane or whatever you want to call it. I should have said line probably, cutting through the middle. Yeah, definitely should have said line. And you're going to have a maximum or minimum value that will be on that line. We call it the axis of symmetry. And I abbreviate it all the time. You'll see me write AOS when we're doing that. So if you see AOS, I mean axis of symmetry. And the neat part about having these symmetric parabolas, if I find 2 points with the same y value, say where y is 0, the distance from the point, each point to the axis of symmetry is identical. So I can do a lot of neat things with that. Likewise, if I was up here, imagining that was the same height, the distance between each of these 2 points to the axis of symmetry is also identical. A parabola has a few key points that it's always good to know about. The first and probably the most popular one is the vertex. It is the maximum or minimum y value, so the bottom or the top of the parabola, actually, vice versa. So here's the maximum, because parabolas can be either way. This vertex on the picture is a minimum. You'll notice that the vertex falls on the axis of symmetry, and that's nice because if you figure out the axis of symmetry, that means you've got the x value of the vertex. And the vertex also centers the parabola in the x direction. The x-intercepts have a lot of different names, and this gets confusing for people. They're just where the parabola crosses the x-axis. And now it can do that twice. It can do it once if the vertex is on the x-axis, or sometimes you just have a parabola that never makes it to the x-axis, and that's fine too. When you are crossing the x-axis, y will be 0. So if you had some numbers, I see that I look at this example, I have one x-intercept that is -1, 0. And if I count to the one on the right, I see that it is 3, 0. So it'll always be a number with a 0 in the coordinates. Now the problem is these are also called solutions and roots. I would say roots are pretty common. Solutions, actually, I see that all the time too. So just know that if you see someone asking for a root or a solution, they're talking about the x-intercepts. The y-intercept is the same as it was when we were graphing a straight line. It just tends to be not as important for figuring out the shape of the graph. It's just where you cross the y-axis. And it's the point where x equals 0. So if I look at this one, I see that my x is 0. And if I count down, my y-intercept is -3. So now we're going to talk about the different forms that we can have in an equation for a parabola. The parent graph is f of x equals x squared. So that's a standard parabola before we've done any transformations, which means we could move the vertex around, or we could squish it, or we could stretch it, or we could flip it. And those change that parent graph. Our 3 forms are factored form, which we've seen, standard form we've seen as well, and vertex form, which we'll go into a bit today. Now, if we're in the parent graph, that y equals x squared, they're all going to be the same. But a typical example of factored form might be something like this. And if we wanted to change that graph into the same equation but in standard form, we'd use FOIL or our array to expand it, and we would create this equation. Different forms of the equation, same graph. If we wanted to make that into vertex form, now I've done a little work beforehand to figure that out, but how do I know that I'm the same? Well, expand this one. So if I took it and I went set up for the binomial expansion, and then I do the binomial expansion, leaving that 16 behind, and then I can drop the brackets, and if I sum it up, there we are. So noticing that when we expand the vertex form, we get back to the standard form. If we were to factor the standard form, we would get to the factored form. They all work out. So looking at factored form, it's written as a onto x minus s onto x minus r. And the thing that you can find very easily from factored form are the roots or the solutions or the x-intercepts. And that's how I tell people to remember that the s and the r mean a solution and a root, which are going to be the two x-intercepts. So notice there's a subtraction sign there, so it just gets a little funky when you're trying to figure out what your roots actually are. So looking at example 1 here, we see that we have x plus 3, and I'm just going to ignore the a value for now. We'll deal with that later. And that will give me my, so this does not play into my x-intercepts at all, but I know that my form had to be x minus s, x minus r. So knowing that, how do I make x minus s into x plus 3? It's if your solution is actually negative. And then just double bracketing to show what's going to be my x-intercept. So here's 1, and here's 2. So I know that for this parabola, my roots are -3, 0, and 1, 0. So whatever else this parabola looks like, I know that at -3 and 1, it is crossing the x-axis. Now that's a lot of thinking. I just tell people, look at what's in the brackets, change the sign. So if you see a 3, x plus 3, you change it to a -3. If you see a -1, you change it to a +1. And that gives you your two actual roots that go onto the graph. Looking at number 2, we have f of x equals 4x onto 2x plus 7. Another way to think of it is that you can find values of x that make y 0. So how do I make this happen? And this is where you get that name solutions from. Any x you see, if you make it so that it's a value that creates a 0, 0 times something is 0. We went over a bit of this before. So if I change this x to a 0, 4 times 0 times 7 equals 0. So one of my roots is going to be 0, 0. And if I look at this part, it's not immediately obvious. It's not x plus 7 where I can yell out, oh, the solution's x minus 7. So you can do some math. You need to make that binomial equal to 0 to make the equation true. So you can do a little bit of algebra and find that x is equal to -7/2, which means my second x-intercept will be this. And if I were to graph the points for my second question, I see one at 0, 0, and then one just past that -3 here. But I need to find out more about what's going on with this parabola. So looking for those key points. So key points for any parabola tend to be the vertex, the x-intercepts, and the y-intercept. That's the thing you kind of have to be able to find from any form. So let's go through how we're going to do that for factored form. We already found the x-intercepts, s and r. If I want to find the y-intercept, I'm just going to find f of 0, which means set x equal to 0, and find out what the graph is doing when x is 0. So that means if I was doing it from factored form, we'll go over in a second, I would make this 0 and this 0 and find out what the equation spits out. That would be my y-intercept. To find the vertex, you're going to take the two roots you just found, the actual ones, not the ones from factor forms, the ones that appear on the graph, and you're going to add them together and divide by 2. What that will do is tell you, so let's say we have a graph here, the point halfway between those two x-intercepts. And because a parabola is symmetric, it's going to tell you where the x value of the vertex is. Once you've got that AOS, or the x value of the vertex, you sub that back into the equation for any x values, and you see what it spits out that time for f of x. Let's look at actual examples to make that a little clearer. Here we are back to our other graphs, our old graph. So we knew that the x-intercepts from this were -3 and 1. I have dropped the coordinate, but make sure you're clear about what you found. So we've got, let's say, 1, 2, 3. There's one x-intercept and 1. There is the second x-intercept. So let's find the y-intercept. Well, looking at my little cheat sheet there, I need to find what f of 0 is. So I'm going to take -2, replace x with 0, and I'm going to get -2 times 3 times -1, which should give me 6. So the y-intercept is 0, 6. So 1, 2, 3, 4, 5, 6. So this really shows me something about what is going on with this parabola. Now I need to find the vertex. So we're going to start by finding the axis of symmetry using the x-intercepts. Add the two x-intercepts together and divide by 2. So we're going to have -2 divided by 2, which gives me -1. Sweet. So that is the x of the vertex. So I've figured this out. If I go v for vertex, I know I have -1 as one point, so I know it's going to happen here. I'm trying to sketch in an axis of symmetry. Now I just need to find what the y value is when x is 1, plug it into the equation. f of -1 equals -2 times -1 plus 3 times -1 subtract 1 equals -2 times 2 times -2. And that's going to give me 8. So there it is. My vertex happens when x is 1 and y is 8. So I'm just going to take it up. Woo, it's going to be right about here. And that gives me enough points to sketch that graph. So here we go. A little bit ugly. Should look like a U. Oh, I missed. And there we go. I missed again. You know what I was going for. All right, let's look at number 2 in purple. We had already decided that our x-intercepts were 0 and -7/2, which we can think of as -3.5 if you want to. So I'm going to put 2 dots there. So theoretically, you could be like, oh, these are going to be the same parabola. But it's not described by just its x-intercepts. We've got to see what the other key points are. To find the y-intercept, we're going to go f of 0 equals 4 times 0 times 2 times 0 plus 7. So we're going to end up with 0, which makes sense because we see this point right here. So we know that the x-intercept and the y-intercept will be 0, 0. Just reset bad Larry. And next we're going to find the vertex. We're going to start by taking those two x-intercepts, adding them together, and dividing by 2. You can work in decimals or you can work in fractions. I need to brush up on my fractions, so I'm going to do that. And I'm going to get negative 7 over 4. That number is going to leave me a little bit shy of minus 2, minus 1.75. So once again, my graph is terrible, so I know I'm expecting a vertex somewhere where that little tiny dot I just put in, there's my axis symmetry. I sub negative 7 over 4 in for x, and we're going to have 4 times negative 7 over 4 times 2 times negative 7 over 4 plus 7. That is heinous, and I think I'm just going to have to try and grab my bad Larry here and throw them somewhere else, so bear with me. I'll just put them right up here so I can continue on. Okay, there we go. All right, so doing some math there. I'm going to switch to red for a second. These will cancel, and I'll have negative 7 in front. 2, that becomes 2. So I've got negative 7 over 2 plus 7. So in anticipation of fraction math, negative 7 over 2, I change 7 over 1 into a fraction over 2, plus 14 over 2. And I get negative 7 times 7 over 2. Back to purple as we're getting close. So that means it's negative 49 over 2. I'm going to write that up here. So I have my second one, if I stay in fraction form, negative 49 over 2. Okay, so that means my vertex is basically negative 29.5 in the y direction. So it's way down there. I'm not going to see it. So I will just, for this sketch, take it like it's going somewhere. And there's my second parabola. Very different than the first, even though the roots were kind of close together. Let's head back to standard form. So we know that's written as f of x equals ax squared plus bx plus c. What can we tell from this form? C will be the y-intercept of the parabola. So you can read that directly from the equation. If you wanted to get the roots, you know how to find the roots from standard form. That means factoring. Thought you were done. Or you can use a quadratic formula, which will spit out the roots exactly. So looking at this question here, I will need to find the y-intercepts and the roots. Well, the y-intercept is going to be 6. So I know a point on this graph will be 0, 6. And if I want to find the roots, I'm going to check if it's factorable by common factoring first. X squared plus 2x minus 3. And I can factor within the brackets, and I will end up with x plus 3, x minus 1, which tells me my x-intercepts will be negative 3, 0, and 1, 0. If I want to find the vertex, I've found the roots. I can do what I did before. I changed it to factor form. I can add them together, divide by 2 to get the axis of symmetry, and then plug that into the equation. But there's a nice quick cheat for standard form. To find the axis of symmetry, or the x of the vertex, you can do negative b over 2a. So looking at this example here, I have negative b, which is negative negative 4. So careful with your signs. Over 2a, which is 2 times negative 2. The c value does not matter for this. And then when you do that, you're going to have positive 4 over negative 4, which gives you negative 1. So, and then from here on, we're just going to plug back into the equation. So finding f of negative 1 equals negative 2 times negative 1 squared minus 4 times negative 1 plus 6. So that gives us negative 2 times 1, negative 2 plus 4 plus 6 equals 8. And there we are again with that vertex equals negative 1, 8. So heading over for a couple examples, we want to find all the key points and we want to graph this. So looking at number 1, right away I see the y-intercept is 3. I'm going to throw that on. I'm going to do the vertex next. So I need to find the axis of symmetry. which is negative 2 divided by 2 times negative 1. So very careful with your signs on this. Equals 2 over negative 2 equals negative 1. All right, there we go. We're going to take that negative 1 and sub it into the equation to find the y value of the vertex. Negative 1 squared minus 2 times negative 1 plus 3. And we're going to get negative 1 plus 2 plus 3. And that should give us 4. So our vertex is negative 1 comma 4. And if we put that on, it'll be 1 up from that y-intercept. The last step is usually to find the x-intercepts, or could have done that first, whatever floats your boat. I'm going to factor out the negative just to see if it's factorable. Keep using the same example so I know it's going to be, and we're going to get negative x plus 3 x minus 1. This tells me the roots are the opposite of what we see in the factored form, so we're going to have one root at x minus 3 and one root at x plus 1. And there's our parabola upside down, maxing out at x equals negative 1 and coming back down. Looking at our second parabola, start with the x-intercept, the y-intercept, pardon me, which is going to be somewhere up here. And let's head over and find the vertex. Negative b over 2a, negative 7 divided by 2 times 3. This is looking like it's going to be gross again, so be it. We get 7 over 6 for the x. So I know that the vertex for this one will be 7 over 6, slightly more than 1, comma something. I'm going to sub it back into the equation to find the second value, or the y value of the vertex, pardon me. Squared minus 7 over 6 plus 6. And I'm going to stay in fractions just to do it. So we're going to square first. So 3 times 49 over 36, 7 squared over 6 squared, minus 49 over 6 plus 6. In anticipation of needing the space, I'm once again going to move my cheat sheet out of the way. Put it up in the corner. Okay, so I'm going to switch to red. Oops, I did not switch to red. Try again. 3 goes into 36 12 times. So I have 49 over 12 minus 98 over 12. So changing 49 over 6 into a fraction over 12, plus 6 times 12 is 72 over 12. That will give me just shy of 2. Gross. And if we're going to plot that one, so slightly more than 1, slightly higher than 2, here's my vertex. And to get my x-intercepts, I'm just going to factor it. So going back to the AC and the B line, I need to multiply to positive 18 and add to negative 7. Is there anything that's going to do that? Nope. So I am stuck using the quadratic formula. So quadratic formula time, we're going to do negative 7, which is positive 7, plus or minus the root of 7 squared, which is 49, minus 3 times 4 times 6, which is 72, and here we stop. This parabola has no roots. So I'm not going to be crossing the x-axis, which makes sense if you look at what you made so far. To get to the vertex, which has to be a maximum or minimum, you needed to go through the point 0.6. So if you're sketching this, just kind of mirror it on the other side, and you're done. Not typical, for questions, but it can happen. I'd like to abandon standard form after that crap example, and let's head over to vertex form, which we didn't really investigate before. So when we see vertex form, it's written as f of x equals that a value, and then we have x minus h plus k. And the neat thing about this is that the vertex are the two numbers you see there, h and k. So 4 quick examples, just to get how that plays out when you're looking at equations. For example 1, h, it's positive, so h must have been -2. K, and k you don't have to mess with the sign. So the vertex of f of x is -2, -1. Looking at my second example, h, k, 4, 7. So flipping the sign of the x and not messing with the y. Number 3, x squared minus 5. So this looks a little different. So I'd like you to think of m of x equals x minus 0 squared minus 5. So this is a k value right here, but we only had x squared instead of x minus h squared because the x of the vertex was 0. So if you see just x squared minus number, the vertex is going to have an x value of 0, and then that -5 is the k or the y value of the vertex. And looking at n of x, h is -3, but there is no k value. So you can think of like plus 0. So make sure you recognize, especially 3 and 4, how those look. And this is awesome. You've got the vertex already, your major point. How do we find our key points when we're in vertex form? We got our vertex, y-intercept, same thing, f of 0. Sub in 0 for x and do the math. The x-intercepts are a little more complicated. You can expand to standard form and factor or use a quadratic equation. That's a lot of work. Or you can set the equation equal to 0, so have 0 equals your vertex form equation, because that will tell you where the graph is crossing the x-axis. So let's do an example here. So if I want to find the y-intercepts, I'm finding f of 0, 2 times 0 minus 4 squared minus 32. And we're going to get 2 times -4 squared, which is 16 minus 32. And we're going to end up at 0. So our y-intercept is 0, 0. That kind of tells me something about one of the x-intercepts or the roots, but let's do the math instead. So if I want to find roots, so I'm going to do this method, because the second method I know we already know how to do. It's just time consuming. So here we go. So 0 equals 2 times x minus 4 squared minus 32. And this is all algebra. Move the 32 over to the left side where it becomes positive. 32 equals 2 times x minus 4 squared. Divide out the 2 from both sides, and you're going to be at 16 equals x minus 4 squared. At this point, to undo a square, we're going to take the root of both sides. Root 16 equals root of x minus 4 squared. On the right side, that just leaves x minus 4. On the left side, it leaves plus or minus 4. Because -4 squared is 16 and 4 squared is 16. So we didn't really talk about it too much. Some people knew it already, but that is a thing I should have addressed, and now I'm addressing. All right, so that means we have 4 equals x minus 4 as one equation, and if I rearrange that, I will get x equals 8, and I also get 4 equals x, or sorry, -4 equals x minus 4, and that means 0 equals x. So our two x-intercepts are 0 and 8. So if I was going to put this graph together somewhere, let's go here. I know that my vertex from the equation is 4, negative 32. I'm going to just put a dot at 4, what I'm calling 4, because it's going to be way low. I know that I have a y-intercept here, which is also one of my x-intercepts, and then my other one is at 8, 0. And if I wanted to draw this graph, hopefully someone would give me an appropriately sized graph. It's going to meet up somewhere down below my writing. Another example of key points from vertex form. So let's start by finding the vertex. -1, -2. Not bad. I'll put that on. So we're going to go -1 in the x-axis direction and down 2 in the y direction. Okay, so now we're going to find the y-intercept, and we do that by finding f of 0. 0.5, 0 plus 1 squared minus 2. So f of 0 is going to be 0.5 times 1 squared, which is going to be 0.5, minus 2, negative 1.5. Here it is. So that was 2. We're just going to put it there. So I can see already that my vertex is a minimum just by looking at what's happening with this graph. I have a bottoming out and then a y-intercept that's up from there. So let's figure out what our x-intercepts are. So changing f of x to 0, the 2 goes to the other side. I divide both sides by 0.5. I take the root of both sides, so I get plus or minus 2 equals x plus 1. And this tells me I can split into two equations. 2 equals x plus 1, or -2 equals x plus 1. Rearrange. For here, it'll be 1 equals x. And for my second one, it'll be -3 equals x. Those points are going to go on my graph. X equals 1, and x equals, let's say, -3. And we kind of get a slightly fatter parabola, which doesn't connect the dots, apparently. You may have noticed I've been ignoring the a value in front. All three of the forms had an a there. And what that a value does, it describes the shape of the parabola. The vertical change. Has it been stretched? So is it a thin parabola, or has it been compressed? So it's like you sat on it and made a wide parabola. And that kind of relates to our sine and cosine graphs where the amplitude, right? If we had an a value of 2, we stretched it, made it a taller graph. And if we had an a value between 0 and 1, we squished it and made it a shorter graph. And it works kind of the same way for parabolas. So your standard parabola where a equals 1 has a certain rule for what we call a step pattern. I like the step pattern for graphing because you can do it quick and dirty. It can make you lazy. So what it means is every time you go over 1, you go up 1 first, then you go up 3, and then you go up 5. That doesn't mean it's 1, 1, 3, 5. That would make a straight line. That doesn't make any sense. But notice on this picture, I go from 0 to 1, 1. And then when I head over to 2, I do 1 plus 3 is 4 is my next y coordinate. And then if I head over to x equals 3, I do my previous y coordinate at 4 plus 5 equals 9. And on the negative side, because it's mirrored, you have the same pattern. So if you get one side, you can draw the second side. So let's see how that looks on the actual graph. So I've got my step pattern, my standard one if a equals 1. And you'll notice they kind of play into figuring out other things. 1, 3, 5 is always what you start with, and you're going to multiply it. And so it'd be 7, 9, and so forth. Multiply it by whatever you need. So in my normal graph, I'm counting up, from 1 to 4 is 3. From 4 to 9 is 5. And it creates this graph. I'm just going to call it y equals x squared instead of f of x because it's shorter. All right, so let's go to our second one, where the step pattern, if a equals 2, it creates this graph. If that's all you're changing, the parent graph, doubling it. So what happens? You take your 1, 3, 4, 5, sorry, and you multiply by the new a value. So 1 times 2 is 2, and 3 times 2 is 6, and 5 times 2 is 10. So that changes your step pattern. So before, you went from 0, 0 to 1, 1. Now you're going from 0, 0 to 1, 2, because your step pattern is 2. The next one you have to go up 6, which brings you up to 8 already, and now we're off the picture already. Okay, and you can mirror that on the left side in the negative, because parabolas have that symmetry. Looking at our third situation where a is 1/4 or 0.25, you take your 135 and you multiply it by the step pattern, and it gives you the change in y for each step. So when you go over x to 1, you're only going up to 1/4. And then when you multiply 3 times 0.25, the next step has to be 0.75 up in the y direction, which takes you to 2, 1. And then as you go to number 3, you multiply 5 times 0.25, and it takes you up 1.25. So you're back over here. And you can mirror that without doing any math or calculations in the negative. So here is y equals 0.25 x squared. And any time you have these a values between 0 and 1, you're going to get this compressed, wide, flat parabola. And the closer you are to 0, the wider it is. The closer you are to 1, the closer it is to the parent graph here. If you have a is greater than 1, you're going to get the blue situation, like y equals 2x. The higher the a value, the thinner the parabola, the more rapidly it goes up. So this is a handy trick for graphing. What if the a value is negative? Well, what happened in our trig graphs if we had a negative a? It flipped the graph. So it's going to do the same thing for our parabolas. It's going to flip the graph around the vertex. So the black line is this graph. My vertex is at 1, 3. And then my step pattern is 2. So I know that I go over 1 up 2, and so on and so forth. If I make the a value negative, it doesn't change the vertex. Looking at this vertex form, it's still 1, 3. But the step pattern is negative 2 times 1, which means negative 2, which means down 2, and so forth. So negative a values create the frowny parabolas. So think of negative as a frown and positive as a smile, and you'll already know what way your parabola should go without even graphing it. You know if it opens upward like this or downward like this. So let's say you're asked to graph and you forget everything and you don't know what to do. So I would always say find the vertex and then go from there. You have some tricks that you can use. So looking at this question here, I know that my vertex is going to be negative 3, 5. So do know how to find the vertex from vertex form. So what does that tell me? When x is negative 3, f of x is 5. And if I forget how to get all my other key points, just kind of walk around these values. So let's say we go, stepping 1 down left and stepping 1 at a time right. Let's find, well, these ones are the easiest one. Let's find these values. So if I plug negative 2 into the equation to find f of negative 2, I'm going to get negative 2 plus 3 squared plus 5. So that's going to give me negative 1 plus 5, or 4. And then if I do the same thing with negative 1, I'm going to get negative 1 plus 3 squared plus 5. And that's going to give me 2 squared, which is negative 4, plus 5, is 1. Okay, so I'm going to plot these points before I go to the other parts of the graph. X is -3, y is very approximate, 1, 2, 3, 4, 5. Y is 5. Okay, x is -2, y is 4. Thinking about an a value being 1 means a step pattern is 1, 3, 5. And if x is -1, y is 1. Parabolas are symmetrical. What does that mean is happening on the other side of the parabola? Same pattern. So you can find 3 points, then find 2 more with no work. And graph that way. So find the vertex, find a couple points heading one way, and then equidistant in the opposite direction, either to the left or to the right, you will have the same y values. So this matches here because you're 1 away from the vertex, and this matches here because you are 2 away from the vertex. Ideally, you get it and you get your 3 key points, but if you don't, this will allow you to barf out a graph. The last thing I want to mention is graphing higher degree polynomials. And it used to be we would do things that had factored form, so you could kind of be smart about your zeros and all that. But nowadays, mostly we're just asking you to figure these out. This is straightforward substitution. So if I want to know the value here, I'm going to do this math. And it's just going to be time consuming, but that's all we're doing here. And I'm already onto my graph. We get -176 if we do that math. I'm not going to make you watch me do the math for each one of these. Hopefully things are right. If you sub in -2 for x, you should get -48. If you sub in -1, you get 0. If you sub in 0, that's nice. It's like using the c value. Just 4. If you sub in 1, we're back to 0. If you sub in 2, we're at 24 already. And then if you sub in 3, f of x is 113. So this graph is fairly nut bar. So let's see what we can actually put on it. There's the point 0.04 right from the middle. -1, 0. +1, 0. And if we look at our other ones, we're already kind of off the graph by 2 and 3, so they kind of go down very rapidly and up very rapidly. So what do I know? I know that I came from way down. I probably went up here. I don't know that the y-intercept is the maximum. I could do more table of values to figure it out. I probably went here. There might be another one of these, something like that. So hopefully you would not be asked to graph something so heinous. I think in the questions are usually just fill in the table of values. It used to be fill in a graph, but you don't really know what the graph is doing without more information. So at the end of the day, if you want more information, you can use more values in between these whole numbers to figure out what's happening, or you can use desmos.com to quickly check what the graph of that might look like. That's it for the parabola section.